I do have a voice. Well, that's good. Apply. Huh. Nothing changed. So it's set to 2 here and reprint unknown. See, just need a 1 night rest and the thing is easy to solve because now we have a breakpoint. $95. Yeah, but you know, there is only one child for this position, which should be correct. I think this is the case where the king is at 12. So you have two parents, one where it is at 10 and one where it is at 12. Hmm. Bloody thing kept running. Totally don't want to do that. How come I am searching for where the king is? Is that not printed? Should be printed. Okay, so it prints it for the first one and then for the second one, and then we crash. So it's the last time it prints the parent. Got the parent at that moment. And I believe that was not. That is in fact 10. The rook is at 4-3. It's not the same as before. Why? Oh, fuck's sake. What is this? Hmm. Yep. So this last finished unlocked the mutex, and then Threadball01 started running again, and we missed it. We missed debugging through it, stepping through it. Very much looks like no, I still don't get it. Anyway, the 2 looks, it's already 2 and then it prints unknown. So these, I don't think anything changes. So the unknown is equal to the 2 or what the hell? I need to, let's try it again. Yeah, it bloody hangs because maybe I should not do next. I should first make sure that the other thread is not inside the debug output. So run again. In a minute, I can't just run again, actually. Quit. I have to copy the file back first. Intro.cxx95. Run. And then go to thread 2, which is inside this, which is frame 13. I'm not sure what happens to the other thread. Maybe I should put a breakpoint. No, it is in a breakpoint. Oh, come on, it is stopped, man. How can it start running again unless I do that manually? Okay, I'll just use finish. Nope, it starts running again. Both did run. Most notably that one. Or did they? Yeah, they must have. Arg. Don't get it. Why? Why do we stop in thread 3? Okay, this is thread. I just switch to 2. This is the thread 0. Which should print fatal error. With made in ply, IXD phantom. It's unknown. Made in ply is unknown. It should not have. There is no fatal error because it is unknown. What? Okay, finally we are stopped. We have a thread that is stopped right where the weird thing is happening. I'm trying to debug my program. Yeah, we have we are now this problematic. There's a problem here. If this is unequal classification unknown ply, then we are going to assert here. Wait a minute. We're not going to assert there. We're going to assert somewhere down here, a little bit lower. So parent info classification ply. Yep, and we're going to print that here. And it turns out that this is printing 2. And 2 is not equal to unknown ply because, as far as I know, unknown ply is odd. So definitely not equal. So I have been totally happy with the fact that if ply is 2, that it cannot be equal to unknown ply. However, my debug output then prints parent info. And that prints that ply is equal to unknown ply. What? And now we finally are at line 96 already, unfortunately. So unfortunately, we did pass this point, but parent info should still be whatever it was. So if I would run it, it's going to print 2 for this value. Hopefully I can do that. I think if I to print that, then the other thread might be running, which I definitely don't want. Because it's calling functions. So I don't think we can do that. I mean, I'm not willing to take the risk. So instead I'm just printing parent info. It has this encoding. What is not good, however, is that it has only one child. And we already have that one child. One child has already visited it, which would mean that the number of ply was indeed already set. This is definitely not unknown. I don't believe that this is unknown. I'm too scared to use the debugger now, so I'm going to look at the code. Encoded. Yeah, this. I don't know. Ply is shifted. Yeah, so I want to. I mean, if we call classification, you just get this object, and if we then call ply on that, we call ploy on classification, that would be here. So that is simply shifting it. Oh, okay, now I get it. Yep. Yeah, okay, so no, I don't get it. Well, actually I do get it. Yeah, I think the 7. No, what? Okay, we need to know how big this is. Can I? So const expression equal to number of bits. Okay, I can print that safely. Classification made in ploy shift. No. Yeah. So you're going to shift 5, then we get 3. Yeah, okay, so I think that the least significant bit of this 7 is means that it is a legal position. And then the remaining 2 bits form this 3, which means that it is unknown. So after the shift you have 3, which is equal to unknown. And then we subtract 1. Wait a second to go ahead that. Yeah. Then 1 is subtracted, so then we get 2. That's how the unknown equals 2. So in fact, ploy returns 1 less than what is encoded, and unknown is still encoded as having all bits set. There's only 2 bits for that, so only 2 bits. Surely we need more bits than just 2. Let's see if we can print this. I thought it was 3 or something, or maybe pre-shifted 3. -1. Oh right, this is outside, this is not encoded. I changed it, so it is unknown is now 0. And then we subtract 1 and then we get -1. So I was wrong, it's no longer 3. Unknown would be 0 encoded, and this is not 0. But it's still printing unknown, which starts now to be very questionable. See, my thread is now where? it's now here. So the parent info was already printed. But we're going to print it again. Unfortunately, it is a reference into something that the other thread might be touching. So still can't step through it like this. Maybe we should make a copy of the info. So it is some local variable, and then we can better investigate it. Well, the other thread should never touch the same info, actually. That's the whole reason. That it can be done like this, or we should be able to do it like this. Oh, wait a minute. Now I realize something. That's not true. It can touch the same parent. Or can it? No, it cannot. Surely it cannot. I think I'm dividing the parents over the two threads. So the I, well, yeah, I don't know. So yeah, this is legal and 2 bits making 3. -1 is 2 ply. It also makes sense that this is set because this has already reached the number of children. That would be a bug, but then it's not explaining why it's printing. That it is unknown. That makes no sense whatsoever. Pitch is 0. Another the white rook is at 12. The 12-11 was what I saw yesterday. So and info is all zeros. Number of children is 0. That is also impossible. Looks like the whole thing is 0. Well, you can see that here. Everything is 0, it looks like it. Why? That was the last thing that was printed. That was this line. Yeah, I think there's only one conclusion possible. The other thread changed it. Right when we are printing this. No, it's not possible because we already passed this point. This must have happened because ply is 2, and then we print zeros after that. So it is not possible that the zeros have been changed into a 2 afterwards, after we printed it. Well, actually, everything is possible with threading, multi-threading, but yeah, maybe, I don't know. Maybe the compiler did make a copy of this and stuff. Rather of this. different. It's working on a different parent info. Different parent altogether, I guess. I don't know what those are used to. Jesus. Can const cast also cast volatile away? I don't think there is a volatile cast. Yeah, I don't know. Making volatile wasn't a good idea. To do this, I want to attack volatile on everything. Just don't want to. Remove the volatile. No, I want it like this. Wait a minute. Yeah, this one was printed now. Why do I not see where it is? Hitting the breakpoint. What in the no. That 112 is this thing. In what thread am I? This should be thread 3. Info threads, thread 3 is this one, so I like that one. I'm in this thread. The last thing it printed was parent copy equals bits equals 0, unknown, 0, 0, everything is 100% 0. And this thing is a local thing on the stack, cannot have been touched by the other thread. So parent info is all zeros. That's what it prints anyway. And then a nanosecond later it is not. So then is my printing wrong or something? Now I could step into this one. This is going to print 2. Yeah, because we have that. Now I want to print parent info copy again. Let's add a new line below this one, 98. That prints this again. It seems I have to step into printing to understand what's going on. Quit. Oh great, this thing already asserted. Yeah, I've got to set the breakpoint. Yeah, and now what was it, the next step? No, I have to unlock the mutex from the other thread. Finish. Should have happened now. Yeah, so this printed fatal error here. Go back to the other thread. This one is now here. And we have the parent info copy, which was just printed. And the current thread is that one, which is highlighted, and that wasn't just printed as parent info copy. All zeros, so it prints 0 everywhere. It prints 0 everywhere, but if at this point I print it here, it's not 0. This is not 0, not 0. So this is going to print 2 now. I think I can safely do a next. Frame is now 9.7, so let's do next. That didn't work, I think. Oh, we did hit a breakpoint now. We're not really there yet. So now I can do next. And that indeed prints 2. While this didn't change because it's a local variable. But the last time I printed this thing, it printed all zeros. And I can step into that and see if that happens. Normally I would just do it next now. See if this thing indeed is still going to print all zeros before I step into it, which is a lot of work. But getting here was a lot of work already. I probably still should do it, just to make sure that when we step into this, it's really going to print all zeros. So yeah, I'm gonna do it next. Yeah, and that does indeed print all zeros. But now we have to do everything again, unfortunately. This would highlight the fatal info thing. Where the hell am I now? Still there. Deleting, finish. Da, 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 da. No, I see it. Fatal error here. So threadable 1, I can go back to threadable 1 now. Yeah, info threads. Come back to threadable 1. I am in threadable 1. So I did stop here. Flame. Okay. I don't think it did break yet on line 7. Well, actually it did, because it says, because it said. Hit this breakpoint. So now I can simply do a next, I guess. Yep. So it prints 2, and now we know that if we go into this, it's going to print all zeros. How in the... So this is not all zeros. And I'm going to step into it now. That is going to be difficult. Step. Think I can do a next here. Step. Channel set bootstrap. Can do a finish, I think. Yeah. fuck? That is the other thread, I hope. Yeah, step then. Mask is 0. Step, get a label, we'll do next. Print label. Next. Print on. On is on. Return. Interpret. Nobody knows what this is. Do step, I guess. Start. No, next. Write a margin. The channel label. The marker. White space. Leaving start. Checking on. Either print on. That's probably where I want to go to. Print data. That's still our thing. Let's do it in X. That's the 70 there and the 1 Yep. Data print on. Info print on. What? That's gonna print just always zeros. What? It's just, huh? I think I lost the whole day just now. See my life. Wasted joke. How do you say that if you see your whole life being played in front of you just before you die? So I think the word is flash. I see my life flash in front of me or something like that. No, okay, whatever. Classification. Yeah, okay, so this is completely broken and I just lost the whole day. Definitely. Well, maybe not the whole day, but it's this is the Twilight Zone explanation. Fucking hell. Completely broken. That's nah, why? What is this doing here? Who did this? I really cannot remember. Oh, now I see what it is. This is a copy and paste that I made of the members so that I could write this code. So I just copied all the members, pasted it here, and then I knew, okay, classification, number of children, that's what I have to print. And I forgot to delete it again. And by pure coincidence, the code is valid. It just the members are now changed into local local variables. I should have deleted it afterwards. That's the error. Oh my god. Well, it doesn't fix the bug, but it explains why the printing prints 0 while in fact it wasn't. So now it looks more sane, the debug output anyway. Entering this function with black king at 10, white king at 10, the white rook at 12. But one of the parents has the black king at 11. That would be parent number 1. And that is being handled in thread pool 0. By the other thread. So they do share a parent. Well, these parents share a child. I don't know. I think this must be some race condition. But okay, we begin anew. Hunting for the real bug. Thread pool 0 with info. Bit is 16. It's just a normal position, legal. Mate is unknown. Number of children 3. Visited children 0. And that's for parent 1. This parent says fatal error. Parent info, bit 60, normal, made imply is already set. Number of children 1, number of visited children 1. Parent info copy is the same. Blacking at 11. Entering info. White moves admin blind parents. Failure detected was 2. That's where it happens. So we have thread pool 0 has this parent, and then sets ply2 on that parent. And then later thread pool 1 has this parent and says, wait a minute, it's already set. And since the parent has only one child, I would think that they came from the same child. What is the child position? Thread pool 0. This is the child. 10, 10, 12, 11. Yeah. Well, 10, 0, 10, 2, 12, 11. Is being called by thread pool 0 on y2 move set minimum ply on parents. And this thread pool has same parent. That is being called with the same board. 10, 0, 10, 2, 12, 11. Yep, so that is the bug. You are not allowed to call this function with the same board twice. That's also what assert says. Don't do that, it assert says, and that's what we do. So why is that happening then? I send line. Okay, so core dump apply is set. Already detected before this. Here for thread pool 0. Thread pool 0 is the one that crashes. Let's highlight that one. Fatal error apply is already set to 2. Fatal error parent info is with apply is already set. And that is for parent 0 with the blacking on 11, as we know by now. And then I can grab for this position, it's always the same position, but okay. And then we see that thread pool 1 already did set apply on it. Being parent 0 here, which means that in a minute, this is thread 1 now. No more parents, apply, entering. Here we enter it. Enter this with that board 10, 10, 12, 11, and that happens below as well. That is 001, that is processing parent 2320. So I guess 2320 equals this position. Already saw that the other one was something else. So I would have duplicated parents. Yes, of course I would have duplicated parents. Yeah, in the end the problem was that we entered this function with the same position twice. So we highlight this. And that happens again here. Oh, 2320. Yeah, what? That is twice the same. Okay, well, I'm glad actually. Should be easier. I didn't get it. Okay, so we enter here. It's thread pool 01 is processing parent 2320. And then here thread pool 0 is processing 2320. That should never happen. I blame the AI. Let's just print the processing to get a feel for this. Yeah, that is a shitload. I code this Velcro. Parent 101, 101 increments nicely. Yeah, it's gonna go all the way up till 2000 at least. Let's go a bit faster. Oh, that was too fast. I'm gonna do the slow one. Yeah, it makes a step somewhere that it skips a region, which makes it go too far. Yeah, here's a skip. That definitely does not make sense. I think that explains it. It should not go from 1009 to 1111. I don't think so. Only another step. 101. It just goes 101 at a time, which is equal to the start value. I think it should have started at 0, but it starts at 101. Totally the AI fault and my fault for copy pasting it. Well, I looked at it and I thought it was correct, but apparently it's not. So yeah, every time we make add gaps of 101, then we probably get too far. So this one reaches all the way up till 2320 at the very least, and the other one probably starts a little bit before that. It doesn't. This one starts at 0. What the heck? What the heck? This one does the first 100, yeah, and then the other one continues at 101. Okay, maybe, yeah, the 303 is not processed by the first one. I missed that then. Oh, okay, it's not that bad then. They do alternate. I want to sort on this column. How do I do that? Move the thread pool to the end. I don't know, so let's choose an R here. I hope that this is good. Treble something. I hate this. Yeah. Okay, so there is 101 put in the first thread pool, and then 101 in the next thread pool. It's not 101, it's more. Yeah, well, anyway, I think it's pretty clear what code is wrong. Because at the end we have duplication here. Let's just look at that. Let's rethink this. So I had these two lines generated by an AI, I think ChatGPT. And it is not good. Okay, let's make a drawing again. Oh, I still have my drawing. The previous drawing. So I have I think I calculated the number of tasks already correctly. Yeah, using this thing. So, and then I want to put number of parents. So base number or base number of parents in each task, which would give me base times number of tasks parents. And then we would have missed the remaining, which could be 0, but definitely less than number of tasks. And we will have to solve this by adding 1 to the first rem tasks. Yeah, this is nonsense. Isn't it? Isn't it? Oh no, it's a minimum. It's okay. So task n is 0 and this is also 0. No, it's not nonsense. The parent start here is equal to task times base, but the first rem ones must get 1 added. What does that mean? It must be this formula that's wrong. Guess this must be rem minus 1. For example, let's say base is 5. I can probably do that better in ASCII. Let's say parents number 0. No, should be enough. Well, that's 24 now. Well, let's do 1 less. Puinhouders to the rescue. $23 divided by 7, it's going to be 3, right? Totally. And then the rem is modulo 7, that's going to be 2. So we do 3. This is base in task 0 plus 1 because we add a remaining thing. The remaining things are added here. Task 1, that's also task 0. And then here we want to do 3 times that one, and I still have a remaining one left because we have 2 remaining ones, so this must be 1. And this is then task 2. And then we don't have a remaining left, so this should be then filled with oops. Total number of tasks 7, 0 till 6. The per start should be 0 for the first task, and then 4 for the next task, and 8 for the next task, 11, 14, and so on. Yeah, this is a task N, basically. So this is 0 times base delta 0 times 3 is 0 plus 0 gives 0. I mean that's 0 times 3. 1 times 3 is 3, and we must get 4, so the delta must be 1. And this is 6, so the delta must be 2. And this is 3 times 3 is 9, and also need to add 2. And the rest is 2. And rem is 2. So yeah, actually the maximum value is rem. So why is it not working then? Maybe it is working then something else is wrong. This would give me for task 1. 1 times 3 is 3 plus 1 is 4. Yeah. And then we get 2 times 6 plus the minimum of 2 and 2 is 8. That works. It just works, man. I think the formula is correct. parent end. Oh, this is using the number of parents per task here for the calculate end, so this can also be wrong. That would be wrong, then maybe you go over the end or something, or I don't know, something. Need to calculate parent end as well. Well, parent is not going further than parent end. So parent end is one larger than the last value that should be done for a given task. So I have parent end for task 0. No, pre-calculate that, so we might as well put it here. Parent end is going to be 4, right? Then parent runs over 0, 1, 2, and 3. But this must be 4 because 4 belongs to the next one. And this then must be 8 and so on. Yeah, must be just the same values, but then shifted 1. This must be 11, this must be 12. And so on. And parent end is the minimum of except at the end. What? That should fit exactly. I don't think the whole minimum is necessary. Is it? Yeah, I don't know. It wouldn't hurt. So let's just concentrate on this part. That means that the number of parents per task equals, obviously, the difference between the two. Four. 3, and so on. Yeah. Also looks correct. Task n is 0 or 1, then it's less than 2. So the first 2 get 1 added here. And the rest is just 3. Okay, so we give up. I go make a little test program for the actual values and then hopefully figure out what the hell is going on here. What parent end is calculated inside the task from parent start, it is copied by value, number parents with task copied by value, and the number of parents, which is also copied by value, so it doesn't really matter that much. Number of parents distance. Okay, there we have a problem. This thing is called parents this task, and here I'm using number of parents per. Oh, what? That's not even what I just tried. I just added this. So this should have been that. Why am I using this then? Yeah, that is just the wrong value, right? That is definitely the wrong value. I think we found a bug. Parents this task. And I think the task itself doesn't need to know this value at all. Nor does it need to know the number of parents. We just need to know the parent end. Yes. No, it's still coherent, but it took longer than before. You go all the way till, well, 10 times more now. Yeah, but still the same error. Holy what? Really? Okay, well, are we still processing the same parent then? No. Are we processing the same parent, the same board? That's what theoretically should be happening. to start. Parent 0 is that. Doesn't look like it. No, just entering it once with this board. So what's going on here now? White to move, set parent, classic ply is not unknown ply. Why not? There's a threat pool 0. Fatal error detected. Ply is already set to 18. As you can see here, it is already set to 18. To error detected. It's already 18 here. Maiden ply was already 18 here. Parent 2. What a problem parent is this parent? No. Oh. I have to stop because Okay, yeah, I'll get a visitor. But I don't know when. In 10 minutes, I would say. But I don't know. I don't know. It's just that someone is typing and then it takes longer and longer and longer. Okay. Yeah, this is probably what you get when people type on their phone. Like in this case. We have 10 minutes left. It tells me when it sits that I should be able to find that back. Yep, yep. I don't think I can find this before my visitor arrives. So let's just stop the stream. I don't see it. Nope. Well, at least made some progress. But the bugs are left.